Hello and welcome back to another Orange Coast College Mathematics video. In this video we're going to talk about more ways of finding the area of triangles, circles, and parallelograms for trigonometry. Now normally the area of a triangle is just 1/2 times base times height. However, if we have two sides of a triangle and the angle between those two sides, we can actually find the area without having to find anything else. All we'll have to do is take 1/2 times those two sides, and then times the sine of the angle between those two sides. So let's say that I had angle A, and then I knew the side lengths B and C. So I knew this angle A, and then I also knew the side B and side C. If I knew all three of these things, I would be able to just find the area of the triangle by following that specific formula. We can also do angle C and then the two sides right next to it, or we can do angle B and then the other two sides next to that. All three of them will give you the same exact answer, being the area of that triangle. Now, what happens if I know all three sides of the triangle, but I don't really have a way of establishing the height of the triangle? Is there any way that I can deal with this? And it turns out there is. There's this really nice formula right here, in which the area of the triangle is going to be equal to the square root of s times s minus a times s minus b times s minus c, where s is just going to be 1/2 times the sum of all of our side lengths. Now, this actually has a specific name, and it's called Heron's formula. This is something that we can use where we know all three sides. Now, moving on to circles and parallelograms, nothing has really changed. The circumference is still going to be 2 times pi times r, and then the area is still going to be pi times r squared. And again, for parallelograms, it's just going to be base times height, where h is the perpendicular height. So let's go ahead and try a few problems out. Let's go on down to number 1. Now, number 1 tells us to find the area of the triangle ABC if A is equal to 46 degrees, side B is 4.3 meters, and side C is 6.8 meters. And we want to round to the nearest thousandth. So let's go ahead and just draw a small sketch. So we have angle A, which is going to be about 46 degrees. So it'll look something like that. And then we have side lengths B and C. So C is the longer one, so I'll put C right here. So C equals 6.8 meters. And then we've got side length B, and B is going to be 4.3 meters. And so I want to be able to find the area of this triangle. So let's notice I have the two sides, and then I have the angle between those two sides. Since I have all three of those things, I can use the formula in that first box. Let's go ahead and write it down. So the area of this triangle is going to be 1/2 times B times C times the sine of angle A. And so the area is going to be 1/2 times 4.3 meters times 6.8 meters, and then times sine of 46 degrees. Now, before we actually throw this into the calculator, we need to make sure that we're on the correct mode, because you might be on radians. If you are, switch over to degrees. If you're already on degrees, well then you're set to plug things in. So, plugging all of this in, we're going to see that A is approximately 10.517 meters squared. And that is the area of our triangle. Let's try moving on down to number 2. So number 2 is telling us to find the area of a triangle if we know all three side lengths, being 8.32 feet, 6.23 feet, and 3.45 feet. And we want to round to the nearest hundredth. So let's go ahead and make a sketch. And again, it's probably not going to be perfect. So don't worry if it's not looking very good. We just want a general idea of what we're doing. So I want to find the area of this triangle, but I don't have any angles. All I have are the side lengths of all three sides. Now luckily we just found out about Heron's formula, and so we can go ahead and use that. Now in order to use Heron's formula, I first have to find S. Now S is defined to be 1/2 times the sum of A, B, and C. So S is just going to be equal to 1/2 times 3.45 plus 8.32 plus 6.23, which is going to give us 9. Now we can go ahead and use Heron's formula, which says that the area is equal to the square root of S times S minus A times S minus B, and then S minus C. Let's go ahead and start plugging in things. So we'll have the square root of 9 times 9 minus 8.32 times 9 minus 6.23 times 9 minus 3.45. Now, plugging all this into your calculator and rounding to the nearest hundredth is going to give us that A is approximately 9.70 feet squared. And that is our answer. Let's move on down to number 3. Now, number 3 tells us to find the area and the circumference of a circle with the diameter of 5.4 feet and to round to 2 decimals. So let's go ahead and take note of what was given to us. The diameter is 5.4 feet. Now, we know that we're going to have to use a radius for both our circumference and area formulas. So let's go ahead and find that. The radius is just going to be half of the diameter, so 5.4 divided by 2 is 2.7. So the circumference is going to be 2 pi r, and so we get 2 times pi times 2.7 feet. Now, plugging this into our calculator and rounding to 2 decimal places, we're going to see that C is approximately 16.96 feet. Now, the area of a circle is going to be just pi times r squared, and so we have that A is equal to pi times 2.7 feet, quantity squared. And plugging this into a calculator, we see that A is going to be approximately 22.90 feet squared. And so let's move on down to number 4. Number 4 tells us to find the area of the parallelogram, and we want to round to 2 decimal places. Now let's go ahead and take note of what our equation is. So we know that A, our area, is just going to be the base times its perpendicular height, and so we kind of already have one of those, right? We know that this is 12, but we need to figure out what our perpendicular height is. Now, we're given a few other pieces of information. We know that this is 9 inches, and then we also know that this is 8 inches. Now, I want to be able to find this portion right here. The only thing that I can see really is that this is a right triangle. And so, since we're using a right triangle, we can use Pythagorean's theorem. However, I need 2 sides. Now, I know that this whole thing has to be 12 inches, and I also know that this portion is going to be 9 inches. So the difference, this little piece right here, has to be 3 inches. And so, going with that, we now have 2 sides of our right triangle, and so we can use Pythagorean's theorem. So let's go ahead and draw a sketch of our triangle. So, Pythagorean's theorem is going to tell me that the hypotenuse squared is equal to the sum of the other 2 sides individually squared. So, let's call this h for my height. So, we can say that 8 inches, quantity squared, is going to be equal to 3 inches, quantity squared, plus h squared. H squared is going to be equal to 64 inches squared minus 9 inches squared. And so, h is going to be the square root of 55 inches squared So now I can find the area of my parallelogram. A is equal to my base times my height. Well, we know my base is 12 inches. And then we just found our height to be the square root of 55 inches squared. Multiplying that out and then rounding to 2 decimals, we see that A is going to be approximately 88.99 inches squared. And that is the area of our parallelogram. Well, that's going to do it for this video, and I hope to see you in the next one.